Hello, Tom here. Welcome to a new episode of AP Calculus BC course. Today we're going to talk about finding the area of a polar function. Last episode we talked about polar functions, how to convert it back to normal xy functions, and how to find the slopes of polar curves. If you want to review the topic of from the last episode, click here. Okay. Due to our school's internet, I couldn't finish the last part, which is the areas enclosed by polar curves. Now, to find the area, all we need to do is remember this equation. The area A equals the integral from A to B, which is the upper and the lower bound, of 1/2 r squared d theta. So the r here is just the equation of the polar function we can see later. I'll do a couple questions to show you how to do this. Okay. Now, let's do the first one here. We're trying to find the area of this function. So all we need to do is put in the equation. Area equals, and because it's the whole function, so every polar function starts from 0 and goes to 2 pi. Okay, and then we put in the equation here, 1/2 the r, which is 4 plus 2 cosine theta squared d theta. And normally in an AP Calculus BC test, these kind of questions are in the calculator allowed. So you just plug it into a calculator and you'll get the answer 8 pi. Okay, this is an easy example. Now we move on to the next one. This looks a little bit harder. We're trying to find out the yellow part. So it's a circle with a diameter of 2 and with a radius of 2. And with this equation r equals 5 minus 5 sine theta. To find this, there's a little trick here. We can divide this shape into two parts. One is formed by the circle, which is under here, this part, and the next part, the other part is, let me use the color. Let's try this. Okay, the red part. And because this is polar functions moves in a circle, all we need to do is find out from these two intersection. From here to here, it will be these two red parts of the r equals 5 times 5 sine theta, and then the blue part would be just the circle from the intersection to this intersection. Now let's try to find it out. Okay, we still use the equation a equals the integral. Now let's try to find let's try to find an intersection first. We can just plug it into a calculator and we'll find that this will be theta 0.644 and this will be theta equals 2.498. Okay, now we know these. We can put it into the equation. Okay, let's find out the blue part first. Okay, let's try this. Total area equals the blue part, which is the circle that goes from here to here. It goes from 2. No. Alright, let's do the red part first. Sorry, don't get confused by this. Let's do it from small to big. Okay, so 0.644, 2.498, and then we put this equation into it. So half r squared, which is 5 minus 5 sine theta square d theta, and plus, plus this blue part, integral from the lower part. We have to be careful here. Although this is a circle, this is easy. The equation for the circle would just be the radius, which is 2. And we need to be careful because it doesn't go all the way, it doesn't finish the circle. It does not end at 2 pi, which is here. It ends here. So we need to, the lower bound here would be 2.498. And the upper bound would be 2 pi plus 0.644 to finish this whole circle. Okay, now we're putting the equation times 2 square d theta. Okay, and if we put it into the calculator, which I did, and you guys all can do that, the answer will be 9.631. 9.631. Okay, now that concludes our episode for today and our lesson on polar functions. Thank you for watching, and make sure you subscribe. Click there, subscribe, and thank you. Peace out.